Hi, I'm Derrick Jensen. This is Resistance Radio on the Progressive Radio Network. My guest today is John McLaughlin. He's a wildlife ecologist and population biologist on the faculty at Huxley College at Western Washington University. He studies the wildlife role in Elwha restoration and the effects of climate change on butterflies. We're going to save the butterflies for another day probably, and today we're going to talk about Elwha. So first, thank you for your work, and second, thank you for being on the program.
Thank you for your interest.
So tell people about the Elwha. Presume that people are very biocentric and they care deeply, but they may know nothing about the Elwha. So just sort of start from scratch and tell them about the Elwha River, the dam, the salmon, all that.
Okay, so the Elwha is located on the Olympic Peninsula. Some 83% of the watershed is within Olympic National Park, and the rest flows north, sort of in the rain shadow of the Olympics, so it doesn't get quite as much rain or snowfall as some of the iconic rainforests, but it's still within the Olympic Mountains. It is a place that has a long and diverse and apparently even tumultuous history involving landslides that have naturally dammed the river, and it's a fairly rugged place where both rugged in terms of the terrain, but also rugged in terms of the river. And so the river contains a number of gorges that have some pretty steep rapids, waterfalls, and that sort of thing that have selected for salmon and steelhead with phenomenal jumping ability. So very large fish, some of the largest salmon ever recorded, apparently came to the Elwha. It's also extraordinarily productive, one of the most productive salmon streams, at least in the contiguous states and even parts of Canada. You could probably go up in further up in coastal BC and southeast Alaska to find comparably abundant runs. But it was superlative. It was also the home of the Elwha people who had an intimate relationship with salmon and shellfish on the near shore, and it was basically their home, their identity. And so it has existed that way, they would say, since time immemorial with them. They believe that their creation site is on what used to be one of the reservoirs, and so it's their identity. About 100 years ago, or actually a little over 100 years ago, it was, you could call it, developed as a source of power to anticipate demand and growth in the growing frontier town of Port Angeles. And so the Elwha was dammed with two dams. The lower one, which was built 4.9 miles from the mouth of the river. And so of the 70 some odd miles, I'll use imperial units unless you prefer metric. So almost all of the accessible spawning area and salmon habitat was blocked by that dam, which violated the laws in place that required fish passage before you can build any obstruction to the river. And it decimated the runs, which numbered on, say, an odd year with pinks, maybe 400,000 fish returning, even a whole lot more juveniles coming out, down to maybe 3,000. So you're down to well under 1% of these historic iconic runs, with similar decimation to the Elwha people. So now those dams have been removed through a convoluted process that we could get into if you want, and it is now seen as a grand restoration project. In fact, if you compare the definition of self-sustaining ecosystem restoration put forward by the International Society for Ecological Restoration, it is the largest and most ambitious restoration project on the planet. So it's a place that has suffered some pretty great impacts, but it's also a place where those impacts are being restored, and restoration has tremendous potential and lots of surprises. So it's a really exciting place to work and to live and to participate in that restoration.
So before we move on to that, there's a couple questions I have. One of them is, you mentioned that these are some of the largest salmon. So first, can you tell me how big are some of the big ones, or were some of the big ones, either way? And then second, you said they were great at leaping. Can you say how far they could leap, just so people get an idea? And then third, what species of salmon, and also how many different runs are those are my first questions.
Sure, and I'll qualify this with that I'm a wildlife or terrestrial animal ecologist. Salmon are not my specialty, but working in the Elwha, you can't avoid it. So the largest fish were the Chinook. Steelhead were also quite large, and there the historic data were up to 100 pounds, and that would be about up to the chin of an average sized human being.
So it's a 5 foot fish, basically.
Yeah.
Wow. Okay.
Yeah, really large. And the reason why they're so large is the ability for fish to surmount some of those obstacles would essentially is proportional to the length of the fish. And so what they essentially need is a pool from which they can generate tremendous propulsion and acceleration to leap above an obstacle. And so the larger the fish, the larger an obstacle they can jump. Other species like chum or pink salmon don't jump very well at all. So it doesn't really matter so much the size of the fish. It's more in their nature. So it's really the steelhead and the Chinook, but there are some very large fish.
And how high can they jump?
That you'd really have to.
So, are we talking? What's a high jump here? Is it 3 feet, or is it 6 feet, or is it a foot? What is a big jump for a fish? Just ballpark. You don't have to be exact.
So I've stared at Rainy Falls on the Rogue River before running in the kayak. I'm watching, and that's a 12-foot drop, and I've watched Chinook jump that. And
how big were those? Were those like 2-foot fish? 3-foot fish?
No, those would be more like 3 foot.
Oh my gosh.
So
okay.
Not near the size of the Elwha salmon.
Okay, so and there were Chinook salmon there, steelhead. What other salmon just generally would run it?
All five species of Pacific salmon. So you got the Chinook, the sockeye, the pinks, the chum, and the coho. You had 2 runs of steelhead. There were char. Let's see, what else am I forgetting? Bull trout. There were 10 runs total, and 5 of those were Pacific salmon.
And were they somewhat? So basically, was this a year-round food for the local?
Oh, entirely. Yeah.
So basically, there's almost always a run going on, or quite often.
There's almost always a run, but they also, they're a people that's very closely adapted to the land, and so they were also feeding on shellfish out at the mouth of the Elwha and along the coast, which was also disrupted. In fact, eliminated habitat for the shellfish they would eat due to the dams eliminating sediment from the river. So
before we talk about the restoration, can you talk about some of the secondary effects of? I mean, obviously, if you put in a dam with no fish passes, that meant that there was no fish. There were no fish on the, or no anadromous fish on the upper 70 miles or whatever of the river. So can you talk about some of the secondary effects of that What happened when the fish were removed? What happened to other wildlife? Do we know?
We know some.
For
We don't know
example, you
enough
just said
about
that.
most wildlife, but
For example, you just said that the dams harmed the shellfish. Can you talk about the sediment for just a moment? Because I don't think that's one thing people don't think about very much is how dams starve the ocean of sediment. Why is that important?
sure. Well, you can really think of a river system as almost a circulatory system on a landscape,
Hmm.
and that circulation moves in both directions. So you have water and material and organisms moving downriver, and you also have primarily organisms, particularly fish, moving upriver. And so it's really the means in which different parts of the landscape are connected to each other, and the land is connected to the sea. When you put a dam that blocks moving water, then you basically stop circulation. Some water can still get down, but in a very regular way, and in a very different form than it does in a wild river. That water is now essentially filtered by the dam, and the flow regime is entirely different. The other thing that happens, to answer your question directly about, so you think about, anything moving upstream is now stopped, and so that cuts off that half of the circulation, and things moving downstream are also strongly filtered. A lot of things don't make it down, particularly juvenile salmon, and so the circulatory system is cut off. But for sediment, moving water will carry objects in it, particularly talking about sediment, cobbles, sand, rock, gravel, in proportion to the third power of the flow regime. And you probably remember this from your time in studying engineering. When the third power of zero is zero, and that's what happens when you hit a reservoir. Everything drops out. And so in particular, these rivers that are born by glaciers in the Olympic Mountains, which are essentially grinding rock into flour and gravel and sand and even cobbles and boulders, all that settles out into the reservoir. And so the reservoir is trapping sediment. And sediment, gravel, sand, and everything else is not getting past the reservoirs, in particular in this case the upper reservoir. And so then everything below that is starved of sediment, of gravel, of sand, of everything else. And so what happened in the century these dams were in place is the lower river got none of that. And so that means that what used to be a sandy beach and now has returned to a sandy beach, but what used to be a sandy beach now became large cobbles. And so the sandy habitat in which clams and other shellfish bury themselves was no longer there, and so they disappeared. The ones that were there died, and they didn't reproduce, and so you lost them. In the river itself, you have salmon, which build their nests. So they basically create a nest of gravel in which they bury their eggs. That's very important because the eggs need oxygen that is provided by moving water, but they don't want the eggs to be flushed down by that moving water, so they bury them in a nest of gravel. Well, if you don't have gravel, then they can't build a nest and they can't reproduce. And so the lower river was starved of gravel as well, and so you lost all spawning habitat for salmon, even below the dams. So the short answer is the sediment provides essential habitat structure, provides the very substrate. I wouldn't call it ground because it's in the seawater, but the very substrate in which the shellfish grow. It also provides the land on which many riparian plants grow. And so the rivers move, they meander, they shift around. You get a flood causing the river to shift in one place, and where it was now is substrate or land on which forest can grow. Well, if you're removing all the sediment, then you don't have the substrate in which that forest can grow.
And then presumably it was not only humans who were unable to eat the salmon who once moved upstream. I mean, when you have a 100-pound fish and you got 400,000 of them, I recognize not all of them are 100 pounds, but you have, let's say, 400,000 fish who are, 50 pounds each. That's a lot of protein that's moving up the river that is no longer going up there to be eaten by bears, elk, and ultimately eaten by plants because the bears are going to poop it out. So I'm presuming that there were cascading effects from the dams then further up.
Right. So what you're talking about is essentially salmon, anadromous salmon returning to rivers to spawn, providing what we call marine-derived nutrients, or essentially nutrients from the sea, bringing back to the watershed. Here you're talking about almost 1 million pounds a year of nutrients, essentially fertilizing the forest. My colleague here, Jim Helfield, is the guy who actually measured that effect on tree growth, and he compared the growth rates of trees growing along streams with salmon runs, and compare that with those without salmon runs. Controlled for other factors. You essentially have otherwise comparable growth conditions, and he found that where you have salmon, trees grow 3 times as fast.
3 times faster.
3 times faster.
So instead of growing a foot, it grows 3 feet this year, or whatever.
Yep. And so what that means, a few things. You get a much lusher forest, and you have a lot more nutrients and consequently energy. Those trees are basically using those nutrients to fix energy, which then becomes available for the rest of the system. And so you have a much richer system that becomes available for everything else. If I talk about the trees for a minute, if your trees growing that fast, well, trees actually create habitat for salmon because the trees shade the streams, keep the water cold, and they also occasionally fall over and create wood in streams, which creates habitat for salmon. So the salmon are essentially, they're not only providing food for their own young in fertilizing the stream, but in fertilizing the surrounding landscape, they're providing habitat for themselves. So that's an interesting thought that again, you're cutting that off. Regarding your question about everything else, people have found the best the estimate that I've always heard is about 137 species of wildlife feed on salmon. I think that's probably an underestimate. I think that's the classic Western scientific reductionist approach to trying to tally the pieces of the system. With this kind of abundance, salmon are an essential component of the system, and so really everything is affected, and in this case enhanced by salmon. But if you really want to be picky, you can say 130 species of wildlife.
Okay, so I want to bring up one more thing before we actually talk about the restoration, which is I just want to give a shout out to Pacific Lampreys. I presume they were there too, and the only reason I want to mention them is because they don't get mentioned often enough. Salmon are the sort of charismatic ones, but lamprey are really important too, and so I presume lamprey were there too.
I believe so.
Okay, I just wanted to give them a little shout out. Because there's lamprey in the stream right next to my home, and it makes me very happy. So just a pretty short version of what was the political process of restoration? It was, I do know, I lived in Washington for 10 years, and I know that they wanted to take it out, but it was not funded for a long time. So can you give just a very short, superficial overview of the political process of getting the dams to go out?
Sure. Well, I guess you could start from when they first went in. Some of the Elwha people were protesting from the very beginning, and from their initiation, the Elwha people were advocating for not building them and then removing them. And so we got to give credit to them from being there all along. Mm-hmm. So then what really got things going was the relicensing process. So the Federal Energy Regulatory Commission is charged with licensing dams. And back in the 70s and 80s when all this started, it was more or less a rubber stamp. There might be conditions put on dams, but it was pretty much almost a sure thing that a dam was going to be relicensed, and you may have to improve things a little bit from when it was built. And that's the context in which this occurred. The tribe, of course, was didn't want to relicense them; they wanted it out. And then there were a number of advocates for rivers and for fish that also thought, "Oh, it'd be great to get these out, but that's a radical concept because that we relicense dams. We don't take out, especially a working dam that's providing some electricity and has been there since the memory of most people alive." And so then what people caught on to was the upper dam, the larger Glines Canyon Dam, was inside of Olympic National Park. And so that meant jurisdiction over its licensing and the whole process might not fall to the Federal Energy Regulatory Commission. And that led to a federal court decision. So the Ninth District Court, one level below the Supreme Court, judge ended up ruling that, yes, in fact, jurisdiction did follow the Department of the Interior and the Park Service. And so the license was not renewed, and that commenced a process of review of what we should do with it. So then in 1992, the Elwha Restoration Act was passed, which called for complete restoration of the ecosystem, and particularly even in the title called out the salmon, or the anadromous fishes. And so then a series of environmental impact studies were conducted, which concluded that we cannot fulfill that goal without removing the dams. The problem was there was no money allocated for that. In the year 2000, money was allocated to purchase the dams, but still there wasn't any money to remove them. And then commenced a whole series of postponement in the process for removing the dams because there wasn't money. And so the National Park lead on this, Brian Winter, went through a series of very frustrating announcements where he announced that the date for initiation of dam removal got pushed back again and again and again. So finally, when the recession hit, the latest recession in 2008, that led to an interest in shovel-ready projects to put people back to work. And retired Congressman Norm Dix determined that this fits the criteria. This is a shovel-ready project, and he managed to get funding for it in an appropriations bill. And so then that actually moved it up from dam removal initiating in 2012 to 2011. And now it is essentially complete.
And so what about the process of, before we started recording, you talked about collaborative restoration. I don't remember the exact term you used. Can you talk a little bit about what physically happened and then what you mean by a collaborative process with wildlife?
All right. So my interest is in collaborative process with wildlife, but the process has also been collaborative with various local groups, a whole variety of federal agencies, university researchers like myself, and so it's been a impressively collaborative process from the human side with people working together to, once it was determined, okay, this is going to happen, and this is going to be a good thing for just about everyone involved. Even the river outfitter, who looked to lose his business because of all the impacts, was supportive of the process, and so he's one of the people who would be most severely impacted. He's the owner of Olympic, Morgan Colonel was the owner of Olympic Raft and Kayak. He was even supportive of the process, only he stood to take some of the greatest financial losses. So it's been an impressive story of scientists, managers, various agencies at local, state, and federal levels working together. But what really gets me excited is the potential of involving of partnerships and collaboration with beyond the human world. And so when this was initially proposed, the Army Corps of Engineers did some analysis. It shows that it's not feasible to take out these dams because it would be too expensive. The reservoirs have accumulated over 20 million cubic meters. That's, probably 25 million, almost 30, but probably about 25 million cubic yards, if you want to use those units, of sediment. And so that was all stuff that accumulated mostly in the upper reservoir, but some of it in the lower reservoir. That happens in all reservoirs. Basically, reservoirs trap sediment, and they fill up. And so eventually all dams have to be removed or basically they become plugged. That's a much bigger issue in the Colorado River system where you have a lot more sediment, but that's another story. So what to do with the sediment? Well, it's going to be too expensive to dredge that stuff, particularly in places that are difficult to get to. And so it's dismissed as being unrealistic. And so then a guy named Tim Randall, who I think is the Western Regional Director for the Bureau of Reclamation, had a creative idea and thought, well, what if we let the river do the work for free? Rivers move sediment, and here we have a river, and we have lots of sediment from that river that's accumulated over a century. What if we let it do the work? And then suddenly the price tag went way down to the realm of possibility, and that's basically what's happened. We decided to work with the river and set things up so the river can be most effective, and that's what they've done. The work that I do considers wildlife as an essential partner. And so essentially what you have is these 700 or 800 acres of valley bottom that used to be old growth forest and then was clear cut and buried by a lake, and then all the sediment coming in those reservoirs. And so essentially you have almost a moonscape. When you drain the water and see what's underneath, you see the incredible destructive effects of dams. Converting, again, what was an old-growth forest into this anywhere else you call an utter disaster. And the question is, okay, the goal is to restore that to old-growth forest. How can we do that? How can we do that in a way that gives us old-growth forest and doesn't give us a great big weed garden, or that does it sooner rather than later so that we can restore fish populations sooner rather than later, or at all, before they might otherwise go extinct. And so we want to restore that as soon as possible, and we can try to do it ourselves by planting lots of trees and helping them to grow. But there are two issues with that. The first is if you plant trees and elk and deer eat them, all you've done is work really hard to create a bunch of deer and elk pellets, and that doesn't give you an old-growth forest. The other thing is there's not enough in the budget for the restoration, for the replanting, to do all that. The planting crews, the revegetation folks are really bright. They're really creative. They work really hard, but they're under-resourced. They don't have enough people, and they don't have enough money, and they don't have enough time. So what we can do is involve animals that might help them. And so one of the things I work with is birds.
Wait. Can we back up for a second?
Sure.
And I love what you're saying. It's great. I want to picture this. So I want to. So the Elwha, at one of the places you're describing, how wide was the Elwha before, the actual channel, where the reservoir ended up? Was it 30 feet wide, say, and then the old-growth forest just went out from there? And then when this sediment built up, did it raise the level of the ground, say 5 feet, 10 feet, 2 feet? How much was it raised? I'm trying to picture it before and after. Do you see what I'm trying to say?
Absolutely. So the reservoirs are dams were built in canyons behind or just downstream of valleys. Mm-hmm. And so the reservoirs backed up in valleys. When a wild river hits a valley, it often will braid mm-hmm. or meander or move mm-hmm. around. Mm-hmm. And so in these valleys now and in other parts of the river that still are valleys, they tend to form multiple channels.
Okay.
And that's what's going on now. Mm-hmm. But where it forms a single channel, it might be 30 or 40 meters.
Okay.
Right, so almost 100 feet.
Okay.
And then the valley itself might be 500 meters wide. So,
okay.
So, a relatively small portion is water, and the rest is forest in various stages of development. The river, periodically in floods will take out portions of forest mm-hmm. and then move over and create. So you have a range of different ages. It's a very diverse system in that sense. Mm-hmm. And then to answer your question about the sediment, essentially what you have is moving water carrying sediment of various sizes, everything from little tiny clay particles all the way up to fairly large boulders, depending upon the magnitude of the flood. That moving water carrying all that stuff hits still water in the reservoir, and everything settles out. And so because that still water is upstream, the first things to settle out are the bigger rocks. And then gravels move a little bit further, sand moves a little bit further, and then the fine clay particle sediments move even further. And so essentially what you have is a wedge, or a big triangle, that forms where the river first enters the valley, extending down towards the dam, with very little actually getting to the dam. That wedge, Elwha is a surreal place, particularly immediately as they were lowering the reservoir and you see all this stuff. You had, 40, 50, 60, 70 meters of sediment. So 70, if you got down to the river.
70 vertical meters?
Vertical meters.
So you raised not you, but the elevation of the area was raised by 230 feet.
Something like that.
Okay. Wow. Okay.
The dam itself was 210 feet, so maybe 70 meters is a little bit of over an estimate. So it was almost as high as the dam itself.
Okay. Well, that's okay. Well, I'm glad I interrupted you then, because that's extraordinary. Okay. So great. So then the dam comes out, and they're using the river to carry the sediment out somehow. And then, sorry, I interrupted. So go ahead now to your birds.
So essentially what we have is this vast plain of bare sediment, right? You can think of a big area of sand, or in some of the fine sediments, such as a mudflat. And we want to grow forest there. And we don't have the resources, the humans, and the budgets to pay them to plant that whole area. And even if we did, the plants aren't likely to survive. If you've ever tried to grow anything in dry sand, you get the idea of what they're up against. And so the first thing is to actually get the plants started and get them out there. And so the revegetation crews have been doing a lot, but they can't get everywhere. And so what I've been interested in is, birds are flying all around. And some of those birds eat fruits, and those fruits contain seeds. That's the purpose of a fruit, is to entice a bird or something else to eat it and then to carry the seed somewhere else. And so if we can, so the birds are doing that, and some species of birds will fly from the forest into open areas, and then they poop out the seeds, and so the seeds get this little packet of fertilizer, and they get an open space with lots of sun, and they can grow into plants. And so that's the idea, is birds are doing that. If we can set things up to attract the birds to the places where those seeds are going to be most effective for restoration, then we've effectively supported them or increased the effectiveness of them as restoration partners. And so there are a couple of ways in which that can be most effective. First is actually getting them out to the areas that need plants. So the sediment, the bare sediments, but also places that plants are going to survive. And there's several things. It's a very difficult place for many plants to grow, because for several reasons. The sediments themselves have very little nitrogen and other nutrients, and so it's a very difficult place for many plants to grow. The second is that they dry out. Again, particularly in the coarse sediments or the sands, water basically drains that really rapidly, and so you're trying to grow things in dry sand in a dry summer, and so it's really difficult for things to grow. And then the third is you have all kinds of deer and elk running around eating that stuff, particularly in the winter when other plants aren't as available. And so the first thing is just get the birds out there. The birds are out there. The thing is to provide conditions to which they're likely to fly to and disperse seeds. And that turned out to be relatively easy because the birds that are doing this, any bird living in a forest, most of those are going to be prefer to perch on things rather than run around on the ground. They will run on the ground, but their first thing they're going to fly to is an elevated perch. Think of try and use the psychology of a bird for a moment. The world is full of potential predators, and you don't want to land on the ground without looking where you're going. And so they tend to land on an elevated perch and then fly to the ground if they're going, or to another perch. The only perches out there are logs, and there are lots of logs, both flushed down by the river immediately and historically. You have logs brought down by the river that end up floating on the reservoir, and because it's wood, it floats, and because there's a lot of wind, the logs eventually get pushed to the edges of the reservoir along the old shorelines, where it accumulates in great amounts but doesn't do a whole lot ecologically. What we really need is the wood in the middle, where there's bare sediment. And so the river itself will do some of that. The river will flush down and pick up wood from various places and deposit it in the middle of the reservoir, but there's also this centuries of accumulation of wood on the edges of the reservoir. And so that's where we can, and the restoration crews have, help the birds, basically work as partners with them by providing that wood in places they can go. And so Park Service restoration crew had a couple of days of helicopter time in their budget, and they used that time to pick up wood from the edges of the reservoir and put it more towards the middle where they want to grow forest. And what that does is it provides perches for birds who are then going to fly out of the forest with fruit seeds in their guts, poop out those seeds in places where they're going to be valuable for restoration, and there you go. The other thing that the logs do, if you have logs oriented east-west, that means you have a north side of the log, which is going to be a little wetter and a little cooler, particularly during the summer. So the plants are going to survive better there. If you have a cluster of logs, then you may have spaces in which deer and elk have a harder time getting to, and so you have a few years in which the plants can get a start and grow bigger. And so providing that woody structure is how we can work with wildlife, both things like birds that play a positive restoration role, and deer and elk, who in their efforts just to feed themselves will slow down restoration. So that's what I mean by essentially working with wildlife as partners. They're there, they're doing things, and if we work with them, then the restoration itself becomes more effective and faster.
I just love what you're saying. This, honestly, all the things you're describing make me giddy. This is so cool. I love this.
Well, so, we can take this a step. Yep.
Yeah, please do. Please do.
No, we can take it a step further. You know, our society is trying to figure out climate change, and particularly effects of water. Well, beavers have been doing this for for far longer than human history has recorded, and we've removed most of them from the land to feed the fur trade, and because beavers create wetlands, and that becomes inconvenient for some landowners. Beavers can be very effective partners in helping us deal with climate change and restoration of other kinds of things. So that's an example where this theme can carry over into all kinds of other endeavors.
So you have talked about acting in this partnership. Can you talk about the effects? It's been the dams were removed, and you said the dam removal began in 2011, right?
Right.
And when was it completed, the actual physical removal of a dam, of the two dams?
In October of 2014. The lower dam was fully removed after about a little over a year, and then the upper dam was higher, more difficult to remove, and there was about a 9-month pause. Most of the budget for the dam removal or the restoration process went to building a fish hatchery, levees, and a water treatment plant for the city of Port Angeles, because they expected all the sediment to come down and to it turned dark gray. It was full of sediment. You don't want to drink sediment. You have to filter it out. And so they had to design a water treatment plant that is going to be able to filter out all that sediment, and they did. That again took most of the money. The treatment plant failed, it failed at about 10% of the design capacity, because what they didn't factor in is all the fine woody debris, the Douglas fir needles and bits of leaves and everything else that ended up clogging the filters. And so they had to pause while they fixed that. And so otherwise the thing would have come out sooner. But it was October of 2014, so a little less than a year ago. It was fully complete.
Okay, so we have about 6 or 8 minutes left, and before we get to a sort of wrap-up questions, can you talk about what has happened since the dam came out? How has it worked to have the river take out the sediment, and how have so far the partnerships with wildlife, and how quickly did the salmon go back upstream? How quickly? Just tell me what's happened since, in terms of the
Sure.
real world.
Sure, and again, I don't see all this, and so my answers will be partial. But we are not in control of everything, and one of the major driving factors in this is what the weather does. In particular, what kind of flows do we have in the river? We get big floods, because you really need big floods or flows to move that sediment. We didn't get that during all this process, and still over half of the sediment was flushed out, which is what the original intent was, and so that has essentially been achieved. As time goes on, even more will get flushed out, but at the diminishing rates, because we're going to be we're essentially growing forest on there to stabilize that, because what they wanted was to flush out as much as quickly as possible. That clouds up the river and impacts salmon, but then have that end so the salmon can restore. To answer your question about salmon, immediately, within days of removal of dams, the fish were swimming past them, and so the salmon response was immediate. In terms of questions about how wildlife has been responding as partners, they've been responding. It's a little bit early yet to assess that. We've been you recall the experience with the Yellowstone fires, where in 1988 a third of the park burned in a fairly patchy pattern, and before then people believed that aspen couldn't grow from seed. And then when they discovered afterwards is yes, they can. It's just there's so many elk around eating the young aspen that they don't get to see anything. That all changed with wolves coming in, moving elk around, and seeing all that. Well, the same thing's happened here, where if you go into the upper Elwha, you do not see young cottonwoods at all. There's several missing generations. And now, just like in Yellowstone, we have these huge expanses of habitat or substrate for cottonwoods to grow on, and they have been. You can get places that it's almost impossible to walk through. The cottonwoods and the willows and the alders are so thick. That's generally in the fine sediments, not so much in the coarse sediments. And so the plant response has been sort of binary. It's been very rapid and impressively so. So imagine something 4 meters high in a couple of years is how high, or 2 or 3 years is what you're getting with some of these cottonwoods and willows. That's pretty fast, and in densities that are again almost too thick to walk through. And in the coarse sediments and sands, it's been really slow, and a lot of the planted cedars have been dying because they don't get any water in the summer. So that's going to be a really interesting process to work with. The other wildlife, it's really too early to tell yet. The places that are getting all these willow thickets, we're getting the birds you would expect to get in willow thickets. So basically the birds have been responding to habitats. But some of the research that I've done, if you want to talk about some of the birds of old-growth forests, well, that's going to be a few centuries, a couple of centuries before we get them. And so there, essentially, what you have is the impact of the dams being lasting at least twice as long as the dams were in place. So the answer is diverse.
Well, this all the stuff about the cottonwoods and about the salmon going up really quickly, that all makes me really happy. So what do you foresee for the what are the next steps in the restoration of the place, and what new partnerships are you looking forward to? And then after that, I guess the closing question I'm going to ask is, how can these lessons be applied elsewhere? So first, what are the sort of next steps there in that region that you either A, foresee, or B, would like to see?
Okay, so the salmon swam past the dams at the first opportunity, and so they went upstream and spawned. It's too early yet to see the results of that. So in a few years, when the offspring of those salmon come back from the ocean, then we get to see, all right, what's going to happen. As expected, it's going to take a couple of decades for salmon to really increase to substantial abundance. So we'll get to see, where we are on that time course. Meanwhile, the plants will continue to grow. The budget for the revegetation is going to run out pretty soon, and so basically what we're left with is some monitoring. Folks like me running around and a bunch of other people recording. All right, how severely are the deer and the elk affecting the plants? Which plants are they affecting? Which ones are making it? And are we on track to reestablish old growth forest, or do we have something entirely different going on? And so at this point, it's really a process. The dam removals are complete. The removal of sediment is, always has been, now it's still entirely up to the river. The tribe has put in a bunch of log jams, and the river has shifted those a little bit, but they put in log jams that are going to stay. And so they've restored a lot of the woody structure on the lower part of the river. And so we get to see how that's happened. The nearshore environment, where the river meets the sea, has undergone an incredible transformation that will continue. And so there's now shellfish habitat, there's beaches, you have surfers out there, and all the marine fish and wildlife interacting with it. So that's undergone a complete transformation, again, which will continue. So we'll start to see the recolonization of the habitat by many of the nearshore animals, including shellfish. Is that pretty much, is that addressed?
Have you, oh yeah, that's great. And you said shellfish habitat. Are the shellfish re-inhabiting yet?
They are, yep.
Oh, that's great.
Again, it's not the work that I do, but those who do have documented by film and something recording data a tremendous shift in what's out there. So you're getting the shellfish back. So there's one thing that's missing though are wolves, right? So the whole thing with the Yellowstone, that has been transformed by reintroducing wolves in the environment, which shift around deer or shift around elk in that case. We don't have those here, and that's a whole other can of worms, so to speak. And so that's something that would speed the restoration even faster, but for a variety of reasons they're not here, and so that's just a limitation we're dealing with.
So we have like a minute left. What are some of the, if there is someone listening to this who is working on restoration issues of whatever sort in another part of the country, in Maine or Florida or something, what are the larger lessons would you like to impart to them from this experience? How can this help other people who are working on restoration elsewhere?
What I would suggest is, again, look at your partners. Pay attention to everyone else who's there. And by everyone, I mean the things with feathers and the things with feet and the things with gills, and understand the whole system. Because, again, a river integrates a whole system. And if you're just acting as a small number of human beings, you're missing the majority of it. And so try and work with nature rather than independently of it. And you'll be much more successful. The other thing is a lot of it's beyond human control, particularly flow regimes and weather in river systems and many other things. I guess ultimately what I would suggest is to spend some time with the system, not worrying about restoration targets and goals and collecting data, but get to love the system, get to know it, get to love it, get it in every cell in your being. And that will carry you through the inevitable slowdowns and disappointments and frustrations and loss of funding and any of that sort of thing. I take inspiration from the salmon, from the birds and everything else that are doing what they do regardless of the odds. That's essential. And same thing with restoration in this part of the country and other parts of the country, the odds are against us. And the forces preventing restoration from obstructing other dam removals are pretty substantial. And it's going to take a deep love of the system and care for it that's going to lead to persistence that will lead to the kinds of successes we're seeing in the Elwha.
Well, that is, thank you so much for that. I would like to thank listeners for listening. My guest today has been John McLaughlin. This is Derrick Jensen for Resistance Radio on the Progressive Radio Network.